to discuss about Newton's laws of motion, which are basically known as laws of motion. We all know that Sir Isaac Newton's work is regarded as one of the most significant contribution to the science ever made by an individual. Many of you might not be knowing, but the calculus, it is also a part of the creation of Sir Isaac Newton's work. But right now we are going to discuss about the laws of motion regarding the physics. Okay? That is a contribution by Sir Isaac Newton, and which is one of the finest invention throughout history. So the laws of motion are basically related to the forces. So let us first of all discuss the important terms related to the forces. So first term is the force itself. So what is the force? The push or pull on an object with mass that causes it to change its velocity. It is defined as force. So what is the force? It is nothing but a push or pull on an object with mass. Okay, so the object must be having certain mass. So that causes the change in its velocity. If ball is standing ideal, as of now its velocity is 0. Now what happens when a footballer kicks on the ball? So by applying a kick, a push force is applied, and due to that the ball is set into the motion and its velocity is increased. So that is how the change in the velocity came. So it is a measurement of interaction between the two objects. Okay. So there are various types of forces. First one is the gravitational forces. The pulling force by the earth is known as a gravitational force. Next is the frictional force. When you rub against a surface, the friction is offered. If you rub your two hands, the heat will be produced because of the friction. Okay? So in relation to the friction, there is always a normal force that is perpendicular to the surface. Okay? And the reaction force. It is also known as the reaction force. So, next is the tension force. When a string or some metal-like object is stretched from two ends, okay, or one end is fixed and it is stretched along the other end. So, whatever the force is generated, that is known as a tension force. And last one is the spring force. As you can see over here in the figure, there is a spring mass system. When the spring is stretched, when the spring is compressed, and the spring is in ideal condition. Okay, so this is the spring force. Now let us move on to the first law of motion. So it is regarding to the object and the inertia. Okay, so an object at a rest tends to stay at a rest, and an object in a motion tends to stay in the motion with the same speed and in the same direction unless and until an external force is acted on it. Okay, unless and until it is acted upon by an unbalanced force. So what is the meaning of that? If there is some object, it is in stationary or steady position, it will stay forever in the steady position unless and until some external force is applied on it. If an object is in motion, it will continue its motion forever unless and until an external force is applied on it. So that is the meaning of it. So the first law of motion is sometimes known as a law of inertia. Inertia is a property of an object to resist the change in motion. What is inertia? it is a property of an object to resist the change in motion. Okay, an object at a rest remains at rest as long as no net force is acted on it. Okay, an object moving with constant velocity continues to move with the same speed and in the same direction as long as no net force is acted on it. So as you can see over here, there is an example of a ball. Right now it is in a steady position. Unless and until an external force is applied, it will stay forever steady. If the ball is applied with constant velocity, if the ball is moving with constant velocity, it will continue its motion unless and until an external force is applied on it. Okay, so that is the meaning of this first law. So this is the first law of motion by Newton. Coming on to the next topic, that is second law of motion. So second law of motion is associated with the acceleration, and we already know what is acceleration. Acceleration is meter upon second square, distance upon the square of the time. So the acceleration of an object is directly proportional to the net force acting on it and is inversely proportional to its mass. So acceleration is directly proportional to the force and inversely proportional to the mass. Newton's second law specifies how much an object will accelerate when subjected to a given net force. So as you can see, the expression A vector is equals to sigma F vector divided by m. That is the net force divided by mass. So the net force is nothing but is equals to sigma F, okay, summation of all the forces, and is equals to mass into acceleration. Okay, so as you can see over here, one person is stretching the trolley. As of now, only one object is there on the trolley. So the force applied will be proportional to the mass. Okay, right now the mass is low. Okay, so that means the acceleration will be high. Now if the mass is increased the 4 times, the acceleration will be reduced. Okay, if the same amount of force is applied. Okay, so when the mass changes, acceleration also changes for the net same amount of force. So let us come to the next topic, that is the third law of motion. So it is very widely known, for every action there is an equal and opposite reaction. Okay, it is very widely known, for every action there is an equal and opposite reaction. So that is the third law of motion. So the third law of motion describes what happens to the body when it exerts a force on another body. Okay, it means there is some interaction between two bodies, and it describes the effect of that interaction on both the bodies. So when two bodies interact, they apply force on each other that are equal in magnitude and opposite in direction. As you can see in the figure, there is one person standing on the boat. Okay, if he jumps from the boat, means he is applying a force in some direction, so the boat will move in the another direction. So the whatever the action performed by that person has some reaction on the boat. Okay, they are equal in magnitude, but they are opposite in directions. So that is the meaning of that. For every action there is an equal and opposite reaction. So that is all about the Newton's law of motion. Okay.